past decades have been characterized by Japan's commitment to pacifism in the aftermath of World War II. But China's relentless military modernization, territorial disputes in the East and South China Sea, and expansive military presence have raised concerns among Japanese policymakers. China's military buildup, encompassing advanced fighter jets, aircraft carriers, ballistic missiles, and cutting-edge weaponry, has spurred Japan to reevaluate its defense capabilities. Japan's quest to bolster its defenses to meet evolving security challenges has led to the creation of the Godzilla FX stealth fighter. What key features and capabilities does the Godzilla FX bring to Japan's defense posture? Does it have what it takes to tackle the evolving security challenges in the region? Join us as we delve into Japan's new Godzilla FX that can destroy China in 30 seconds. The Mitsubishi FX, also called the Godzilla FX, is a sixth-generation stealth fighter developed for the Japan Air Self-Defense Force. It is Japan's inaugural domestically developed stealth fighter and is scheduled to replace the Mitsubishi F2 by the mid-2030s. This undertaking is not only geared toward enhancing Japan's defense capabilities, but also aims to make headway into the international arms market, signifying a shift in Japan's defense policy. In October 2020, Mitsubishi Heavy Industries was designated as the lead developer for the FX. The FX program originated when the United States banned the export of the Lockheed Martin F-22 Raptor to safeguard its technology, leaving Japan unable to acquire the F-22. Consequently, Japan opted to develop a domestically produced fighter to replace its aging fleet of fighter jets. The Ministry of Defense conducted a study between December 2009 and August 2010 to explore the development of a future fighter jet that would be a generation ahead of contemporary fifth-generation fighters. This concept fighter was named the I-3 fighter and is expected to feature advanced radar systems to counter the stealth technology of other fighters, the ability to receive targeting information from various platforms, the use of flyby optics technology for faster data processing, stealth capabilities, gallium nitride semiconductors to improve radar performance, and a more powerful engine. The development of the FX program aligns with the progress made in the Mitsubishi X2 Shinshin program. The X2 demonstrator was crucial in providing Japan with new information and technology relevant to its next-generation fighter jet. Testing for the X2 concluded in March 2018. In parallel with the development and testing of the X2, various evaluations and research efforts were conducted related to the FX. These research activities sought international collaboration as Japan enhanced its defense capabilities. In mid-September 2019, flight tests were conducted to evaluate integrated sensors for use in the FX. These tests were carried out on an F-2 fighter, with the results reported as positive. In March 2017, Japan and the UK discussed potentially co-developing a future fighter jet. By March 2018, the Japanese Ministry of Defense considered various options for developing the FX, including domestic development, joint development with international partners, or building it based on an existing fighter design. Proposals were sent to the US and UK for participation, and Boeing, Lockheed Martin, BAE Systems, and Northrop Grumman responded. Boeing proposed an upgraded F-15. BAE Systems offered their Eurofighter Typhoon. Lockheed Martin presented a hybrid F-22-35 fighter, and Northrop Grumman expressed interest in joining the project, with speculation about offering a modernized YF-23. However, by October 2018, the MOD began to rule out the possibility of developing a fighter based on existing designs. Boeing's F-15 and BAE Systems' Eurofighter Typhoon were reportedly needed to meet the ministry's requirements. Lockheed Martin's hybridized stealth fighter raised doubts due to its high cost and uncertainties about U.S. export approval. The estimated cost of the hybrid fighter was as high as $177 million per aircraft. In February 2019, the MOD announced it was initiating a Japan-led future fighter program, prioritizing domestic industry involvement and development. Plans to develop or produce existing foreign-made fighter jets were ruled out, and the program aimed to meet 5 key aspects: future air superiority, incorporation of next-generation technologies, platform modification and upgrade capabilities, Japanese industry participation, and cost-effectiveness. The program was slated to occur between 2019 and 2023, with a 15-year timeline for completion. In August 2019, the MOD announced that the development of the stealth fighter would begin between April and December 2020, utilizing the FY 2020 defense budget. By December 2019, 11.1 billion yen was secured for the FY 2020 defense budget to launch the program, with a total budget of 28 billion allocated for FX development. Of this, 16.9 billion was allocated to research projects, and the remaining 11.1 billion yen was earmarked to launch the program and initiate conceptual design. The program's name was officially changed from Future Fighter to FX. In March 2020, Japan rejected proposed designs from Lockheed Martin, Boeing, and BAE Systems as they needed to meet the MOD's requirements. This decision placed Mitsubishi Heavy Industries at the forefront of developing the stealth fighter, though international collaboration still needs to be ruled out, with Lockheed Martin, Boeing, Northrop Grumman, and BAE Systems still listed as potential partners. As of July 2020, the MOD anticipated that the first fighter prototype would begin in 2024, with flight tests starting in 2028 and full-scale production commencing in 2031. In June 2021, Japan discussed with British officials cooperation with Rolls-Royce on engine development. On December 9, 2022, Japan, the UK, and Italy announced their intention to merge their 6th-generation projects into the Global Combat Air Program, effectively concluding the Japan FX fighter program. The FX is a formidable twin-engine stealth fighter, distinguishing itself by its considerable size, leading to its affectionate nickname, Godzilla. This substantial size serves a deliberate purpose by extending the fighter's range and augmenting its payload capacity. Notably, the technological innovations trialed in the X2 technology demonstrator are slated for seamless integration into the FX fighter. Defense Minister Taro Kono has underscored the FX's robust network capabilities and its remarkable capability to carry a more extensive arsenal of missiles compared to the F-35. The intricate design process of the FX commences with the meticulous creation of initial conceptual designs. These designs then undergo a comprehensive examination through an advanced 3D digital mock-up system. These design blueprints are finely tuned to align with the anticipated functions and performance standards of the FX. Subsequently, they are subjected to a rigorous evaluation using a cutting-edge research flight and combat simulator developed by the esteemed Technical Research Division. Within this simulator, a vast dataset covering avionics, stealth features, and engine specifications is meticulously scrutinized by highly skilled pilots from the Japan Air Self-Defense Force. This meticulous evaluation process encompasses air-to-air combat simulations, providing a thorough assessment of the design's efficacy while identifying areas requiring refinement and improvement. In comparison to its predecessor, the FX undergoes significant advancements, notably in the replacement of traditional hydraulic systems with cutting-edge electric actuators to streamline the interior design. The shift towards electric actuators is attributed to the intricate requirements of crafting the aircraft's stealthy form, which accommodates internal weapon bays and intake air ducts. Electric actuators offer a simpler installation process requiring solely electric wiring, eliminating the complexities of hydraulic system piping. This transition results in more straightforward installation procedures, reduced constraints, a notable reduction in weight, and an enhancement in the aircraft's overall maneuverability. These electric actuators apply to the fighter's flight control and undercarriage wheel braking systems. To achieve an agile and lightweight structural design, the FX leverages advanced manufacturing techniques. These techniques involve fusing composite materials through adhesive molding while minimizing the use of traditional fasteners. Heat shield technology is judiciously applied around the engines to allow for the incorporation of lightweight materials such as aluminum alloys and carbon fiber reinforced polymers. Moreover, highly efficient structural analysis methodologies, including using finite element method models generated through computer-aided design, facilitate a thorough examination of the aircraft's structural integrity. The expansion of CFRP and adhesive molding to encompass the entire fuselage is instrumental in reducing the structural mass and streamlining production processes, consequently diminishing working hours compared to conventional methods. Addressing the thermal challenges posed by avionics systems, a dedicated heat transfer system structured after the vapor compression refrigeration cycle, is thoughtfully integrated to bolster the air cycle and liquid cooling system, ensuring optimal performance in managing the heat generated. The FX is equipped with an array of integrated sensors to enhance detection capabilities against stealth aircraft. These sensors encompass an active electronically scanned array radar, a passive radio frequency sensor, and an infrared camera. The AESA radar and RF sensor incorporate advanced gallium nitride technology, resulting in a significant performance boost. For self-defense, the FX features a robust RF self-defense system that excels in countering potential threats from other aircraft, air-to-air missiles, and surface-to-air missiles. This comprehensive system seamlessly integrates electronic support measures and electronic countermeasures, further fortified by strategically positioned ESM body antennas along the fighter's wings and tail flap, enhancing its overall self-defense capabilities. The fighter's helmet-mounted display system is another impressive feature, offering a wide field of vision, a binocular multicolor display, voice recognition, and 3D sound, significantly enhancing the pilot's situational awareness and mission effectiveness. In its pursuit of minimizing radar cross-section, the FX meticulously incorporates serpentine air ducts and an internal weapons bay, contributing to its reduced detectability by radar systems. Advanced technologies such as electromagnetic wave absorbers and metamaterials are judiciously applied to diminish radar reflection and detection range further. Additionally, the FX prioritizes passive detection methods complemented by plasma stealth antenna technology. This innovative technology enables the fighter to deflect radio waves by creating temporary plasma via electrical control, ensuring continued communication capabilities while maintaining its stealth characteristics. During the early phases of development, the FX was initially envisioned to be equipped with two XF9 engines. The prototype engine's specifications, officially disclosed in 2018, showcased a military thrust of 107 kN or more and an afterburner thrust of 147 kilonewton or more. The XF9 engine's versatile design allows for adjustments in thrust levels, catering to varying requirements. The future fighter engine program sets a target maximum thrust of 196 kilonewton, a goal presented at the ATLA Technology Symposium 2018. Among the remarkable attributes of the XF9 engine is its capacity to withstand high combustion temperatures reaching up to 1800 degrees Celsius, all within a compact form compared to its power. To illustrate, the engine inlet of the XF9 is notably 30% smaller than the General Electric F110 used in the F2. This streamlined design is instrumental in accommodating internal weaponry and preserving the aircraft's essential stealth capabilities. The XF9 engines contribute significantly to the fighter's energy requirements, delivering a substantial electrical power output of 180 kilowatts. potentially amounting to 360 kilowatts when combined. This high-energy generation is crucial to sustaining the fighter's advanced avionics and equipment. Furthermore, the engines incorporate innovative three-dimensional thrust vector nozzles, enabling the aircraft to achieve exceptional maneuverability while enhancing its stealth characteristics. These thrust vector nozzles can deflect thrust by up to 20 degrees in all directions, further elevating the fighter's performance and agility. The ASM-3 missile has been specifically developed for the FX to replace the capabilities of the F-2. In addition to this, the FX will feature a cutting-edge microwave weapon designed to disrupt incoming missiles. This microwave weapon is ingeniously activated through the aircraft's ASR radar system, employing electron tube amplifiers for exceptional efficiency and compactness. Japan also plans to introduce unmanned combat aerial vehicles, collectively known as the Combat Support Unmanned Aircraft, which can effectively operate alongside the FX. This drone program parallels projects like the Kratos XQ-58, Valkyrie, or the Boeing Air Power Teaming System, where these drones act as loyal wingmen for the piloted aircraft. Two variants of these drones are envisioned, one designed as a sensor carrier for scouting targets, and the other tailor-made for launching munitions and redirecting incoming missiles away from the parent aircraft. Both versions share a common design philosophy, and these advanced drones are anticipated to reach full development by the 2030s. The development of the X-2 and the FX is widely seen within Japan as a unique opportunity to reinvigorate the nation's defense and aerospace industries while simultaneously establishing a strong presence in the international arms market. In the wake of World War II, Japan's defense and aerospace sectors grappled with significant setbacks, leading to an extended recovery period. Consequently, Japan predominantly engaged in licensed production of US-made aircraft to sustain its industry, historically encountering challenges in creating domestically designed aircraft, whether in civilian or military domains. The development of the F-2 fighter, in particular, was met with considerable controversy in Japan. Initially conceived as a purely Japanese fighter, the F-2 was intended to incorporate Japan's cutting-edge technology and serve as a spiritual successor to the legendary Mitsubishi A6M0. However, the complexities of domestic fighter production, combined with U.S. political pressure, led to a decision to develop the aircraft with the U.S. jointly. This choice, coupled with delays and limited profitability for Japan's domestic industries, resulted in the F-2 becoming a costly and contentious fighter. As a result, Japanese lawmakers and defense officials are determined to avoid repeating the challenging developments experienced with the F-2. The decision-making process between domestic development, which garners favor from defense industry groups and lawmakers, and international collaboration, is rife with considerable challenges. Opting for domestic development poses the formidable obstacles of high costs and the relative lack of experience in creating a domestically produced fighter. On the other hand, international collaboration offers the advantage of cost sharing, yet introduces complexities in effectively coordinating with project partners. Notably, Japanese lawmakers remain steadfast in their insistence that domestic companies lead the project to ensure profitability and safeguard the preservation of the nation's defense industry. However, when it comes to the joint development of the stealth fighter, the United States and Japan adopt contrasting approaches and prioritize divergent aspects, while U.S. defense officials emphasize operational concepts and the requirements of capabilities as the foundation for fighter acquisition. Japanese officials lean towards emphasizing technology development and the safeguarding of their industrial interests. Furthermore, the legacy of the F-2 casts a shadow over discussions between the two countries, raising concerns about Japan's ability to maintain control over its partnership with the U.S., especially in light of the F-2's historical challenges. At the same time, Military cooperation between the UK and Japan has progressively expanded over the years, characterized by discussions marked by open-mindedness and flexibility. Both countries have developed mutual interests, especially in the post-Brexit environment, where the UK seeks partnerships beyond the EU, while Japan strives for some degree of independence from the US to nurture its domestic industry. However, this deepening cooperation has not gone unnoticed by the US. In mid-April 2019, reports indicated that the US was willing to share parts of the F-35's software with Japan to secure a joint development deal for the FX fighter. These reports suggested that this offer was made to outwoo the UK in winning a contract with Japan. The Financial Times reported concerns among US officials that Japan might choose BAE Systems as its international partner over American defense contractors. Consequently, the Trump administration purportedly exerted political pressure on Japan to collaborate with the US, citing apprehensions over potential interoperability issues between a British fighter and US military equipment in Japan, which could complicate joint operations. Some fear that selecting the UK as a partner might have irked then-President Trump amid a dispute over cost-sharing for US forces stationed in Japan. In 2020, the Nikkei Asian Review noted that choosing the UK would provide Japan with more flexibility in developing the FX, while still prioritizing its alliance with the US. In early March 2020, a report from the Nikkei Asian Review indicated that Japan intended to choose the US for collaboration, despite ongoing discussions with both the US and the UK at that time. ATLA responded by stating that discussions with the US and the UK were ongoing, but the report suggested that the US still wielded significant influence over Japan due to their alliance. On August 25, 2020, Japan's defense minister announced they were exchanging information with the US and UK to deepen our consideration of international cooperation in this development project. The development of the FX marks Japan's effort to narrow the gap and respond to the presence of Russian and Chinese stealth fighters. Specifically within East Asia, the FX is Japan's response to ensure it stays caught up to China and South Korea in its pursuit of stealth fighters. The primary motivation behind the FX's design is to address concerns related to military threats posed by China, North Korea, and Russia. The Japanese Ministry of Defense views China's rapid military expansion and territorial disputes in the East and South China Seas as significant security challenges. North Korea's nuclear weapons program and Russia's increased military activities are also key considerations. In the context of China, the FX is intended to serve as a countermeasure against advanced Chinese fighter jets, including the Shenyang J-11, Chengdu J-20, and Shenyang FC-31. Experts anticipate that Japan's development of the stealth jet may contribute to China's uniacy regarding Japan's enhanced military capabilities. Japan's pursuit of the FX, along with China, India, and South Korea's development of stealth fighter programs, represents a growing trend of Asian aerospace industries challenging the traditional dominance of Western and Russian manufacturers in the global fighter jet industry. As of 2018, approximately 90% of combat aircraft in use worldwide are supplied by the United States, Russia, Britain, France, and Sweden. Successful development of the FX and other fighter jets could potentially shift the epicenter of the fighter jet industry from the northern Atlantic region closer to the Asia-Pacific. If exported, it may pose a substantial challenge to the prevailing Western dominance in the fighter jet sector. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there!